Okay, so welcome back to our last lecture together. We are now reviewing the last one we did was we did 16 on regression. We did 17, I think, on more on correlation and regression. We skipped 18. So we are on chapter 19. This was the last portion of the call. Yeah, we did 17 last. Thank you. So I'm sharing my screen now. And here we go. So the last few chapters, 19 was on sampling methods and sampling distributions. The reason why we do statistics at the end of the day is to be able to infer and test things about the real world. So we want to be able to take samples and from those samples to make inferences about the entire population. And in order to do that, we have to make sure that the samples were taken in the right way. And at the same time, we have to understand the mathematics of inference so that we can make appropriate conclusions based upon our sample. And the main idea of sampling is to randomize. You have to make sure that your samples are randomly generated. You can't just go to the mall and pick people who have a pleasant disposition, and as such, you don't think would be bothered if you randomly walked up to them and intruded on their life and bother them in one way or another, like people are wanting to do to me on campus all the time. Yeah, anyways, so randomization, muy importante, very important. And then when it comes to randomization and sampling, we had a list of terms that just are used in every example. They come up over and over again, like what's the population, what's the parameter, what's the sample, what's the sampling error. These are all things that we went over that you should certainly know the definitions of. We did some examples, of course. We did lots and lots of examples. We talked about methods of sampling. Not too much. I mean, you can fill textbooks just on methods of sampling, but the basic idea.
Yeah. Wait, Professor, sorry, I have a question.
Yeah, go ahead.
Is there going to be any multiple choice on the test?
I don't think so, no.
Okay.
The test questions will be like the quiz questions will be like the homework questions. In fact, I will use.
So there won't be like, what is the parameter here? But if it does, we just write it out like, oh.
Yeah, if I ask what's the parameter, you just say the parameter is
blank. Yeah. Okay.
Something like that. Okay. Yeah, so all this stuff, just examples, random sampling, of course, being the very best kind of sampling. That's when every member of the population is as equally likely to be chosen as any other member of the population. You know, if I have a big crowd in front of me and I want to pick people randomly, I'd probably be more inclined to pick people in the front so that they don't have to struggle to get to me. That's not random. I probably wouldn't pick people next to each other thinking, oh, if they're more spread out, that's more random. But the truth of the matter is, no, if it's more random, it could end up being the 5 people right in front of me. It could be the 5 that chosen. It's random. It could be anyone. So it's very difficult for the human mind to construct a random sample. Better let it to be done by chance. Put everything in the hats, shake it around, pick them at random, a random number generator, and so on. And of course, this requirements, this grade 7 curricula is understanding how that we can use a sample to make an inference about the population, right? Here's everyone. We take a sample and we infer from the sample about the population. Well, my sample average was 17.3. So I imagine that my population average is roughly 17.3, probably not exactly 17.3. So there's probably a range around them. Oh, hey, I just figured out what a confidence interval is and so on. So we did that. And then we talked about sampling distributions. And we saw that there's always going to be variance. There's always going to be a spread of possibilities when you take a sample. Even something like the average height of every American, not everyone's the same height. There's a spread of values. There's an average value. And the majority of people are around the average value, but there's still going to be a spread. So the sampling distribution says, okay, we know what it's like for one person at a time, but if I take a sample of them and I take the average of my sample, what does the graph, what does the distribution of that look like? And the main idea is that if you have a sample, a group of them at the same time, the mean does not change. The average of my population is going to be the average of my sample. But the main idea is that the spread shrinks as the sample size goes up. By the law of large numbers, by the stabilization idea from chapter 1, the larger the sample size, the more we hone in on the true value, whatever that value may be. And then we did stuff here, just some examples. And we saw here, right, different size spreads, spread out, less spread out, least spread out. So this will be the sample of size 40, size 10, size 4. Notice that their means are all about the same because even as the sample size changes, the spread, the mean does not. And that was chapter 19. Any questions on chapter 19? Going once, going twice, going tres? No. Okay. So then in 20, we had testing statistical significance. I didn't like this one. It was kind of confusing. But in general, the idea of testing significance was you're curious about the value of something. I think that the value of this is 17. I think it's not 17. I think it's more than 17. I think it's less than 17. You take a sample and you want to infer from the sample whether or not your belief, your status quo belief, if things didn't change, the underlying assumption is valid or not. And the basic idea is, assuming that your assumption is valid, let's calculate the likelihood of getting the result that you did. If it's so unlikely to have occurred, a 0.00003% chance to occur, and it did occur, wait a second, something that unlikely, that just shouldn't happen. So what's going wrong? What's going on? What's the problem? Oh, okay, I think your assumptions are wrong. We're going to reject your assumptions and we're going to look for different ones. This is the idea of testing for statistical significance. We're looking for statistically significant results. That term, statistically significant, know that one. A statistically significant result is one from which we would reject the null hypothesis. If it's not statistically significant, then it could have happened, maybe not the most likely outcome, but it's likely enough that I'm not going to question my beliefs. This is the idea of statistical significance. And while we didn't really go into the details of how to construct these confidence intervals or situations, we did look at this approach of saying, well, okay, we, in this example here, for example, that made sense. In a sample of size 266, 16% of them had white feathers. So if I actually make a simulation of samples of size 266 under the assumption of the null hypothesis, the question is, would I get that result? How likely is it that I got that result? And if you look at it, it's very unlikely to get 16% because it's way off here. It's off the chart. So if you get something somewhere here in the middle, I'm not going to question this. If you get something way on the edges, I do question that. And we did a lot of examples of this. We did this one, we did some more here. There were a few coming up, I remember. Here's another one. And so we did more. Yeah, here's another one. There's a whole page of them coming up somewhere. Maybe it's the next chapter. I guess it was the next chapter. But again, the whole idea is the result statistically significant? Is it weird enough of a result that we reject the null hypothesis in favor of the alternative? Or can it reasonably be attributed to chance, in which case it might not have been the most expected result, but it's not crazy enough for me to reject the null hypothesis. This was the entire idea of this chapter. What's the p-value? The p-value is the likelihood of getting the result that you actually got, or something even more extreme than that. And if it's really small, usually less than 5%, in this case, it's 0.01, which is less than 5%. But if it's very small, then we reject the null hypothesis. If the p-value is low, the null must go. And if the p-value is high, anyone? You guys rhyme? You guys poets? If the p-value is low, the null must go. But if the p-value is high, let it fly or eat some pie. That's right. I think we should eat pie no matter what. That's my personal opinion, whether it goes or not. But yeah, let it fly. Okay. And that was it for chapter 20. Any questions on that one? Now's the time to ask. All right. And then finally, the last chapter that we did, chapter 23. We took a survey and we got 59% of adults did yada, 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 plus or minus 3 percentage points, plus or minus 3. That means it's not just 59%. It's 59% minus 3%, that's 56. So 59 plus 3, that's 62. 56 to 62%. I got 59% of my sample, but let's be honest, it's a sample. It's a sample. I can't honestly say that it's exactly going to be that value for the entire population, but it should be around that value. And I am 95% confident that it's between 56 and 62%. Is it actually between those numbers? I don't know. Maybe, maybe not. But I'm 95% confident that it is. And if I want to be more confident, I just take a wider interval. The more confident you are, think of it like a net. The more confident you are, the bigger the net, the bigger the interval. A bigger interval is more likely to catch the true value. So you want to be more confident, make it bigger. So the margin of error is how much you add or subtract. So it's how much you go right and how much you go left. That is the margin of error. Different confidence levels give different margin of errors. Let's take a look. What else we got here? Well, this is the chapter that had all these things. So essentially what we do is we go far enough to the right and left until we've obtained 95% of our data. And the outside 5%, that's outside my confidence interval. This is how I'm going to be constructing my confidence interval. So we see that 5%. I mean, this is like a fifth. This is a 0.5%. This is 1% right here. So if I go to here, if I add all of these up on both sides, any one of them individually is not more than 1%. But when you add them all together, that's going to be certainly more than 5%. So it's not always the easiest to judge exactly what 5% is, but ballpark figure, it seems like around here to here, give or take, would cut off the last 5%. You're looking for the middle 95%, if it's a 95% confidence interval. Does that make sense? Well, hopefully it does. This is all review. So essentially, if I say, give me a 98% confidence interval, you go out until you feel like you've caught 98% of the data. We did some examples of that, right? We did a lot of these. Lots of fun. We had a few examples of actual vote totals and margins of error. And then we came up with a formula. And then we saw as we went through the review that back in chapter 1 or chapter 2, there was already this formula in a slightly different context. But the relationship between the margin of error and the sample size is given by this formula. So if I say, I really need to know the true value, of course, I'll never know the true value because all I'm doing is taking a sample, but I don't want to be off by more than 1%. 3% above? No, too much. 1% is the most I want to be off. All I got to do is plug in 1% into E and solve for N. And if I want to say, oh, that N's too big. Oh, okay, I'll settle for 2%. I'll be off by 2%. Okay, plug in 2% and solve for N. And this is the formula that you would use in that case. And of course, we want to interpret a confidence interval. What's the interpretation? So when we say we are 95% confident that our confidence interval contains the true value, we mean that if we would keep making confidence intervals after confidence intervals after confidence intervals all the same size, 95% of our confidence intervals will contain that value. That's what we mean by we're 95% confident that we caught it. 95% of our confidence intervals will contain the true value, whatever that value might actually be. Although, of course, we interpret it by saying that we're 95% confident that we caught it. And then we did. And of course, you can do confidence intervals for other things. We don't do in this course a lot of them. You can do confidence intervals for means and difference of means and proportions and difference of proportions and standard deviations and different standard deviations. You can do confidence intervals for the regression equation, the best fit line for the slope. Say my data gave me this slope, but is that really the slope? I want a confidence interval of slopes. You can do confidence intervals for lots and lots of things, and they all have the same basic idea of you have your true value, you have your margin of error, you construct your confidence interval, and we're a certain confidence that the true value is somewhere in there. And that takes us to the end of chapter 23. And therefore, that takes us to the end of the review. So, are there any questions on anything we did?
I have a question.
Yes.
So I don't remember what chapter it was for, but how do you know if it's a right tail test or a left tail test?
Well, in that case, you have to read the question very critically. So if you have a math program at your school and the kids go through this math program and they end up with certain grades, and you come along and you say, I have designed a new and improved math version, and I would like to test my students to see whether or not this new and improved math version will result in better grades. Then we're looking for your new values to be higher than your old values, right?
Yeah.
And therefore the difference between new and old should be greater than 0, should be positive. And the more positive it is, the more I'm likely to say, hey, this works. And that will be a right tail test because I'm on the positive side. Where instead I might say, I have tested my male students to see how well they do in math and my female students to see how well they do in math. And I'm curious if one is better than the other. And there I'm not specifying, do I think the males are better or do I think the females are better? I just want to know if either is better than the other. In that case, either side would be okay and it would be a two-tailed test. Does that make sense?
Yeah, that makes sense. Thank you.
Right? So at the end of the day, it's you got to read the question and interpret it. Very rarely is it going to say, this is a right tailed or left tailed test. You got to read it. And then you got to do this, because without doing this, doesn't tell you anything. It's you start with your palms out and then you come around like that. Okay?
Got it. Thank you.
Any other questions? Comments, similes, metaphors, allegories, anecdotes. Always forgotten that one. Memes, I guess we could say now. Are there any memes? that a thing? Actually, my sister, did I show you this meme that my sister sent me the other day? Was it you guys that I showed it to? No,
No.
it's about, hold on. It really sums up my life, I decided. She meant it as a joke, but it really hit home. This is my, let's see if I can find it. This is it. That's that's my life right there. That's my life right there. Ah, yeah, I keep, I think I'll go on a diet, New Year's, right? January 1st, it's about time, right? This way I can start my diet on January 1st, which is my traditional New Year's resolution. And then I can go off my diet January 2nd, which has been my traditional New Year's failing. So it's really been a great tradition, a January 1st, January 2nd tradition that I've been on for years. So I know it's really tough around this time of year. It really is. I mean, you got Hanukkah, and then you got, you know, all the other holidays. That's right. I'll tell you, I was tutoring a couple nights ago, and you know, Jewish house, and they had these Hanukkah cookies, man. They're on the table, right? These things, and I'm like, oh, cookies. And they're like, help yourself. I'm like, no, you don't want to say help yourself, because if you tell me to help myself, they're all gone. And they're like, no, help yourself. I go, fine. Well, at the end of the day, they were all gone as predicted. That's right, but they were so good. Oh my God, like, you know, like the cookies with the glitter things on top, but they're soft, but they're not too soft, or like that you bite into them and they bend, you know what I'm talking? Oh my God, so good. You've never been to a Shabbat dinner, Michael? Well, I know, right, Harmony? They said that. I warned them. Yeah, sugar cookies. Yeah, that's right. That's right. Some good stuff. Oh, yeah, so I'm off December 19th to December 31st. 12 days vacation. So I gotta find 12 amazing restaurants and do like an amazing meal in all of them. And then start my diet January 1st. And then January 2nd, go back to all of them because I'm off my diet. It's like gonna be a perfect, like I'll know what's good. I know what I can go back to. I already have it all planned out. So it's gonna be wonderful. Meanwhile, so are we all ready for the test on Wednesday? Thursday? Yes, Thursday. Are we all ready for the test on Thursday? Are we all going to be ready for the test on Thursday?
We're going to try.
We're going to try. Just remember, when you hand in your test, any money that you want to put between the pages, you can do so. Just make sure it's clipped on so it doesn't fall out. Test taking just makes me nervous. I'm hoping for the best. That's all I can ask. All I can ask is to hope for the best. Now, Amber, let's see. I do have some emails here of people who requested. Let's see, Amber, I have you here. I have a few others of people who have requested a makeup final. This is my first wow, it's 2 years. That's crazy. So first, there's the on-campus makeup final, which is Monday and Tuesday. And then, as I already mentioned, I am willing, since I'll be on vacation, to meet people off campus at a public location so that we can, Monday after the final. All makeups are after the final. So the final's on a week from today, December 16th. And then we're talking about December 19th, December 20th, something like around there. Is the on-campus makeup the same time and room? That's a great question. I don't know the answer to that. I don't know how many students will be taking makeups and therefore how they're going to arrange them. So I don't know. I guess as we get closer, we'll figure it out. But again, I ask And again, I have Amber who emailed me. I have Tyler who emailed me. Hopefully I'm not, embarrassing or revealing anything I shouldn't, but I just wanting you to know that I did get emails about having a difficult time making it to the test. And as such, we'll figure out by then which room it's gonna be in and where. But yeah, my high school is out by then. College is obviously out by then. All my tutoring will be done by then because nobody wants tutoring when there's no school to prepare for. So we'll certainly find time. And if you can't make the school's makeup time, again, I don't mind meeting people. And yeah, I'll let you know via email. What's everyone taking next semester? I don't care about like things like, psychology or, basket weaving. Like what math are you taking next semester? Geometry, math 310. Is that geometry 310? I think I taught that once. I think I might have taught that years ago. I think. Anyone else? Just are you all like in the same programs? You pretty much all take the same classes semester after semester? Liberal studies. What's that? Is that like a political thing? Liberal studies? Like you study how to be a liberal?
It's like teacher preparation for elementary. So we have like all these like specific classes to take.
Oh yeah, those stuff suck. I mean, it sounds like amazing. It sounds like you're gonna have a lot of fun. That's really, really exciting. Are you all gonna be elementary school teachers? Anyone planning to be a high school teacher, or you're all elementary school? Little kids and stuff, still get them when they're young and
I plan to do high school, but I'm not sure yet. I want to do high school math.
high school math. Oh, so some of you do want to be high school teachers. Well, good luck on that. And it will suck the life out of you. So a master's, that's nice. Elementary, while they're interested, that's great. Now, Michael, being a special ed teacher, that is something that I cannot do. So I have the utmost respect for special ed teachers. I think you guys are wonderful. I can't do that, but that's really just amazing. Mostly elementary, but I've opened to teaching history and Spanish in high school. Yeah, okay. Alex, a master's in what? Yeah, the SAS is too much above 6th grade. Yeah, up to 6th grade. Up to 6th grade, you're still good. And my jokes. Harmony, it's a struggle. It's a struggle, trust me. And some of them have, I'm telling you, some of their jokes in high school. I have 9th graders who are saying jokes that are just so adult. I mean, they're growing up so fast. They know things and talk about things that I didn't learn until like a week ago. I mean, we're talking about like just crazy, inappropriate, but can't help but laugh jokes. That's the biggest struggle. You got a 9th grader saying a sexual innuendo joke. How do you not laugh? It's tough. You don't want to, but you have to. Yes, that's not good. I don't like working with that either.
Professor, you should probably end the recording.
Probably. Yeah, have I said anything bad?
No, but like if we watch it on YouTube or something, it's just gonna be a lot of talking of us just talking.
Oh, that's true. Well, okay, good point. I'll pause it right now.